Hi, and welcome back to today's little foray into the mathematical universe on the quotient rule. As ever, if you're in internet land, probably don't need to do the work I've said, but if you're one of mine, yes you do. Okay, so let's recap. All right, we're dealing with the quotient rule, but I think it's important to always remember that what you are learning here in this methods course is leading to a bigger set of problems. Each of these individual things we've been dealing with so far, differentiating by positive whole number powers. I'm probably going to put money on the fact that you will not get a question in an exam that says differentiate y equals x to the power of 4. Not going to happen. Negative integer powers, that will definitely appear somewhere in the exam, but undoubtedly as part of a short answer or extended response. And again, it's not going to say differentiate x to the power of minus a half. You can guarantee there is a chain rule question somewhere in the exam. Rational powers absolutely will happen somewhere in the exam. And chain rule and product rule, totally and utterly yes. All right, so remember, the chain rule was dealing with questions where you had x squared plus 3 to the power of 3. So what I would say is 1x term, that bracket signified, keeping it together, to the power of 3. That's when we would use the chain rule. The product rule was when we had sort of two x terms multiplied together. So you can see here an x term multiply an x term. But now we get onto this quotient rule. And what is the quotient rule? Well, the quotient rule actually deals with how to divide two x terms, right? Or they don't actually have to be x terms, but let's just stick with the convention of x, right? And please note, we don't always have to use the quotient rule. Right, we might actually choose to make life harder for ourselves and use the product rule. And you're going to say, well, how would I do that? Well, remember, anything on the bottom of a fraction can actually be moved up to the top just by making the power negative. So we could re-express this as x minus 2, and remember that now has to be in brackets, multiplied by x squared plus 4x minus 1 all to the power of minus 1. And then you would make that u and that v, and we know that y dashed is equal to uv dashed plus vu dashed. And we could carry on and do that way. There's no reason why. It would still give us the right answer, but I actually think the quotient rule in many cases might actually be easier. And so, what does the quotient rule state? It states that y dashed is equal to vu dashed minus uv dashed all over v squared. And you're going to say, well, hold on a moment, where's this u and v business again? Well, in exactly the same way as we have for the product rule. Remember, if you had y is equal to x squared plus 3 all cubed, the first term you would call u, the next term you would call v, and you would break out. The same is true of the quotient rule. The top of the fraction is always the u, and the bottom of the fraction is always the v. And there's an example coming up that we'll work on in a moment. Now, word to the wise. If you remember, the product rule was y equals uv dashed plus vu dashed. Well, it was u followed by v. In the quotient rule, it's v followed by u. Where it was a plus here, it's a minus here. So try not to get confused with the two of them. Rubbing that out just to give me some space. So how does it work? Exactly the same way. I do a breakout. So I break out my working out, and I say, well, okay, let u equals x minus 2. So u dash becomes equal to 1. We like that. V becomes equal to x squared plus 4x plus 1. So v dash becomes equal to 2x plus 4. And then substitute it back into my equation like we have here. So I now know then that y dash is equal to v, which we know was x squared plus 4x plus 1, putting it in brackets because I'm taking one term and I'm putting in more than one, times u dashed. Well, u dash is just 1. And I'm going to take away u, again, x minus 2 in brackets, and I'm going to multiply that by v dashed, which is 2x plus 4. And I'm going to divide that by v squared, which was x squared plus 4x plus 1 all squared. Now, I have to do some simplification. I cannot just leave it like that. You have to show it in its simplest form. Multiply that out gives me x squared plus 4x plus 1 minus, now I'm actually going to multiply out my brackets first. So I'm going to get x times 2x, which is 2x squared, plus 4x minus 4x and minus 8, all divided by x squared plus 4x plus 1 all squared. Now, a wise word to the wise, you don't ever multiply that bracket out. Well, No, actually, I don't think I've ever seen an example where you would need to multiply that example out, right? Just always leave it squared. Please don't multiply. You'll make so much work for yourself and it will just look gross, right? Leave it as a squared. Now, did you notice the minus? And the reason I left these in brackets was because that minus is now going to have an impact on everything that I do for the rest of the question. So I have x squared plus 4x plus 1 minus 2x squared. That plus 4x and minus 4x disappear. And then that becomes plus 8. You know, the problem with these questions is not so much the maths. It's the length of time you spend writing out that bottom one and keep writing it squared. So x squared minus 2x squared is minus x squared. So x squared minus 2x squared. 4x has got nothing to simplify it with. And plus 1 plus 8 is plus 9 all over x squared plus 4x plus 1 all squared. And ladies and gentlemen, that is the differential of my equation. All right, so can I simplify this top bit anyway? No, I'm just trying to work out, can factors of 9 make 4? No, they can't. And so there we go. That is the end of my question. And here's another example, slightly more complex. Why? What do you notice here? Well, I've already got a floaty 3 there, so I'm going to have an idea that this is going to be a chain rule question. So not only do I now have quotient rule, I have chain rule in here, but the same thing works. So let's make that u, let's make that v. All right, so u is equal to 3x squared plus 2 cubed. So u dash becomes equal to, using the chain rule, 3x squared plus 2 squared multiplied by, and that's going to be 6x. So let's simplify that to become 6 of 18x, 3x squared plus 2 all squared. So there's my u dashed. V is equal to x plus 1. So v dashed is equal to 1. That's nice. We like that. Thank you very much. And now substituting it into my quotient rule formula gives me that y dash is equal to, so v, which is x plus 1, times u dashed, which is 18x. Actually, I'm going to get rid of that bracket because I don't need it for the moment. So multiplied by 18x, multiplied by 3x squared plus 2 all squared, minus u, which is 3x squared plus 2 cubed, times v dashed, which is 1, all divided by v squared, which is x plus 1 squared, which is slightly nicer to write than previously. Now, what do you notice? I've got that chain rule, which suggests that those brackets are going to be the same, which means I'm going to need to factorize out some stuff. Wow. So let's just write this out neater. And again, probably wouldn't need to do this on an exam because you're going to be time pressured. And you've just got to practice this stuff to make sure that you get it done as quickly as possible with accuracy, by the way. Right, so let me see. What can I factorize out? Well, it would appear the only thing I can factorize out is 3x squared plus 2 to the floaty 2, right? Because that's the only thing that's common to each of these terms. There's term 1 and there's term 2. So that leaves 18x, brackets x plus 1, and I'm going to minus 3x squared plus 2. Why? Because I've taken 2 of them out, 3 of them in total. That's the floaty 1, right? That's all divided by x plus 1 all squared. Now I have to do a bit of simplification. So 3x squared plus 2 all squared. Leave my square brackets in for the moment. So 18x times x gives me 18x squared plus 18x minus 3x squared minus 2 all divided by x plus 1 all squared. And so simplifying and collecting like terms in those square brackets gives me, back to curvy brackets now, 18x squared minus 3x squared is 15x squared, plus 18x and minus 2, all divided by x plus 1 all squared. And there is my final question. Now, if you look at this, as I've said here, these types of questions test the chain rule, the quotient rule, algebra, fractions, differentiation. They are prime exam fodder. All right, really, 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 really awesome questions. And if nothing else, if they don't even appear in exam, they are great practice for you to make sure that you get your algebra and your fraction skills and your factorizing down pat. All right, well, thanks very much. This is the end of the lesson on the quotient rule. Thanks very much for watching, and I look forward to seeing you next time. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to seeing you again.